Hello friends, let us see in this video about the Fibonacci series. Now this Fibonacci series is an infinite series. It is an infinite series. Now this series starts with 0 and 1. The starting two numbers are fixed to be 0 and 1, and the next number is calculated as the sum of previous two numbers. Now this is 0 plus 1 is 1. 1 plus 1 is 2. 1 plus 2 is 3. 3 plus 2 is 5. 3 plus 5 is 8. And it goes up till infinity. It goes up till infinity. Therefore, it is an infinite series. Now, this Fibonacci series has some of the applications as well, which I will post in the description section of this video. And you can see that if I take the next number, what is the next number? 8 plus 5 is 13. 13 plus 8 is 21, plus 13 is 34, 55 and so on. If I take the sum, the division of 8 by 5 is 1.6. 13 by 8 is approximately 1.6. You can see over here 8 by 13. 13 by 8. 8 1 ja 8. 5. 8 6 ja 48. 2. It is approximately 1.6. Now if I take 21 by 13, here 13 and 21, 13 1 ja 13, 8, put point, 13 6 ja 78. Now this 1.6 is called as something golden ratio. Now about this golden ratio you can search in the net and find what is this golden ratio. Now the beautiful things in the world are said to have the golden ratio of 1.6. This Fibonacci series, any number approximately it gives 1 by 6. Right, 3 by 2 is 1.5, but for the larger values you get the approximate ratio as 1.6. Now this is all about the introduction to Fibonacci series. Now we want to write a program to print n terms of Fibonacci series. Now there are infinite terms of Fibonacci series. We cannot go on printing for infinite times. Therefore, we restrict ourselves to print till the first n values. Now, what do I mean by till first n values? Say for example, if I say n is equal to 6, we want to print starting 6 terms. These are the starting 6 terms, 0, 1, 1, 2, 3, 5. Now, how do we print the starting 6 terms? The starting two terms are being fixed to 0 and 1. Now, if the starting two terms are fixed to 0 and 1, that means there might be something previous imaginary terms. Let us call the previous imaginary terms as A and B. Let us call the previous imaginary terms as A and B. Right, these are not part of the Fibonacci series, but they help us to compute the first term and the second term of the Fibonacci series. Now, what it is A plus B should be equal to 0 because sum of these two things should be the next term by the definition of Fibonacci series. And the next thing is B plus 0 equal to 1. Now, if we solve these two, it implies A equal to minus 1 and B is equal to 1. Therefore, what we take, the two imaginary terms, again I am saying, it is minus 1 and plus 1. These are imaginary terms of Fibonacci series. We are not taking as a part of the output thing. Now, how do we write the program for this? Let us see in a moment. Let us see how do we print the first n terms of the Fibonacci series. We say int n, let n terms we want to print. Suppose here n is 5, 1, 2, 3, 4, 5, till 3 we want to print it. And you read the value of n. Now, we assume that let A and B represent the previous two terms of the Fibonacci series. And what do we write over here? We say int A is equal to minus 1 and int B is equal to plus 1. Let A and B be the previous two terms. What are these? These are previous two terms. And we need one more variable. Let us call that as C. And how many variables we want to print? We want to print n terms of Fibonacci series. Hence, we say for I is equal to 1, I less than or equal to n, I plus plus. We know that this for loop will run from 1 to n. And we want to print the n terms of Fibonacci series. Now A is minus 1, B is plus 1, and we will compute the next term as C. And how do we compute the next term as C? We say C is equal to A plus B. We say C is equal to A plus B. That's very simple. Therefore, the value of C will become 0. Now, since this is the first term of Fibonacci series, you need to print the value of C. We say printf percentage D comma C. We have printed the first value of C. Now, what is the value that is being printed? It is the 0 that is being printed. Now, what we said, let A and B be the previous two terms of the Fibonacci series. Now, to compute this one, what are the two terms of Fibonacci series? B and C are the two terms of Fibonacci series. But we said that let A and B be the next two terms. Therefore, A should be shifted over here and B should be shifted over here. And how do we shift it? We say A gets the value of B and B gets the value of C. That is what I write. A gets the value of B and B gets the value of C. Now, when we do this, let me write A initially was -1. B initially was +1, -1 plus 1 is 0. You have printed 0. A gets the value of B. A gets the value of B. Therefore, A is +1. B gets the value of C. Therefore, B is 0. I plus the value of I becomes 2. Let n be 5, 2 less than or equal to 5. Yes, C is A plus B. 1 plus 0 is nothing but 1. Now what we do, we print the value of C. What is the value of C as of now? It is 1. Now again we say A gets the value of B. A gets the value of B, which is 0. B gets the value of C, which is 1. Again you say I plus whatever it is. C is A plus B. 0 plus 1 is 1. And you print the again 1. You print again 1. And you say A gets the value of B. A gets the value of B, which is 1. B gets the value of C, which is again 1. I plus I is 4. 4 less than or equal to 5. Yes. C is A plus B. 1 plus 1 is 2. And you print the value of C. What is the value of C? It is 2. You have printed 2. Next, again you say A gets the value of B, which is 1. B gets the value of C, which is 2. I plus I is 5. 5 less than or equal to 5. Yes. C is A plus B. 1 plus 2 is nothing but 3. Now you print the value of C. What is the value of C over here? 3. 3 is being printed. Next you say A gets the value of B, which is 2. B gets the value of C, which is 3. Suppose I want to print one more term. You say C is equal to A plus B. 3 plus 2 is 5. Next you print 5 over here. Again we say A gets the value of B. A gets the value of B 3. B gets the value of C, which is 5. And so on. You can go on printing up to enter. And sometime the condition will become false. You will come out and we stop the procedure over here. This is how the Fibonacci term is computed. Now, this Fibonacci term can be computed very efficiently by using the matrix method, where we raise a matrix to the power n. Now, what is that matrix? I am just saying it, but you will see in the two-dimensional arrays how we do that. It is 1, 1, 1, 0. If I say this matrix to the power n, the first term will always be the nth term of the Fibonacci series. It will be always the nth term of the Fibonacci series. This is all about the Fibonacci series. I hope you have liked this video and enjoyed this video. Please subscribe to my channel and share the channel with your friends. We are going to solve many more programs with respect to interview, gate, right, and some of the research paper or projects also we are going to do at the end of this. If you like this video, please write in the comment section. Thank you for watching this. Thank you.
For the online paid courses of C programming, data structures using C, and analysis and design of algorithms, you may contact at the given email ID and you may download the following app. The app link is being given in the description section. Thank you.